Hi, welcome to this lesson on calculus. What is the derivative? So let's have a look at deriving from first principles, question 5. So the first derivative, f prime x, is defined as the limit as h approaches 0 of the average gradient formula, f of x plus h minus f of x all over h. Okay, so what am I going to do here? I'm going to do my algebraic gymnastics. So on the right, I got my f of x is 5 over x. So look where the x is, it's in the denominator. So f of x plus h, I replace that, so it becomes 5 all over x plus h. Okay, so again, algebraically, numerator for this fraction is 5, and denominator, it is x plus h. So there are two terms in the denominator. Do not make the most common algebraic mistake and do that. That is not true in algebra. Okay, that is simply not true. If the x plus h was in the numerator and 5 was in the denominator, then you can break it up, but not in the denominator. All right, so now let's go ahead and evaluate that difference. F of x plus h minus f of x. Well, that is 5 over x plus h minus 5 over x. So I have a fraction and I'm subtracting from another fraction. So I need a lowest common denominator. So my lowest common denominator is going to be the product of these two. So it's going to be x times x plus h. Okay, so what do I need to multiply the first 5 by? Well, I need to multiply it by x minus the second 5 I need to multiply by x plus h. So altogether I have 5x minus, that's going to be 5x. And don't forget it's minus 5 times h, so minus 5h. So again, be wary of the algebra. Times x all over x times x plus h. Okay, you see the 5x's cancel here. So you're left with negative 5h all over x times x plus h. Okay, that is f of x plus h minus f of x. So what happens when you divide that entire thing by h now? So limit as h approaches 0. Well, f of x plus h minus f of x, we saw that it's negative 5h all over x times x plus h. And when you divide by h, you are multiplying by 1 divided by h. That's the same thing. When you multiply by 1 over h, it's the same as dividing by h. Again, algebraic properties. Now look there, the h in the numerator will cancel with the h in the denominator. So you're left with the limit as h approaches 0 of negative 5 all over x times x plus h. Now I can evaluate the limits. So it's negative 5 all over x times x plus 0. Well, x plus 0 is just x, so it's x times x. So it's negative 5 all over x squared. So it almost looks similar to the 5 over x. Instead, now there's a negative sign outside the 5. So now the gradients, which is the derivative, right, gradient of the tangent, seems to be a negative 5 over the x term squared. Okay, and again, just to keep reminding you, putting into context, right, 5 over x, that's a hyperbolic function that looks like that. All right? So what we are saying is this f prime x here, this is the gradient of the tangent lines at that point. So if we took x equals 1, for example, 5 over 1 is 5. So there's the point there, 1, 5. Now if you took a tangent line, so let's put a tangent line through there. Can you see that tangent line is going to be negative, and that the gradient of that tangent line is the derivative at that point. And the derivative is negative 5 over x squared, so negative 5 over 1 squared, which is negative 5. So the gradient of this tangent line is negative 5. So again, that's what the first derivative is telling us. It's telling us what is the gradient, right, of the tangent line at a point on the function. Okay, and that tells us the rate of change of the function, how the function behaves, if it decreases or if it increases over time, and so on. All right, so that's the power of the derivative. I'll see you in the next one.